Check out this smooth LED fade effect. Looks pretty cool, right? Today we're going to learn how to create this using something called PWM. Now, what is PWM?
Pulse Width Modulation, or PWM, lets us control LED brightness by rapidly turning the light on and off. Unlike a plain digital signal that is either fully on or fully off, PWM uses fast pulses to create an average voltage. By adjusting the duty cycle of these pulses, the LED appears to dim or brighten smoothly. An Arduino can switch the LED about 490 times each second, too fast for us to notice flicker. Thus, PWM gives the illusion of analog dimming while using only digital outputs.
Now here's something important. Not every pin on the Arduino can do PWM. Only 6 pins have this capability. They're pins 3, 5, 6, 9, 10, and 11. Look for the tilde symbol. It looks like a little squiggle next to the pin numbers on your Arduino board. If you see that symbol, the pin supports PWM. For this project, we'll be using pin 9. If you try using a regular pin like 7 or 8, PWM won't work. So make sure you're using one of these 6 special pins. Let's look at what you'll need for this project. The good news is we're using the exact same components as Project 2, an Arduino Uno R microcontroller, a small breadboard, 2 jumper wires, and resistor 220 for LEDA cable for coding, and last 1 LED, I have a sack of those. First, take your LED and place it on the breadboard. Make sure it goes across the center gap. Remember, the long leg is positive. That's called the anode. The short leg is negative. That's the cathode. This is important because LEDs only work in one direction. Next, take your 220 ohm resistor and insert it into the breadboard. Connect one end to the same row as the LED's long leg. The other end of the resistor will connect to our Arduino. Resistors don't have polarity, so either direction works. Now take a jumper wire and connect the LED's long leg on your breadboard and other end on Arduino 5V. Now take a jumper wire and connect the LED's long leg on your breadboard. Finally, connect Arduino pin 9 to the resistor. Remember, pin 9, that's one of our PWM pins with the tilde symbol. And that's it. Your circuit is complete. I'm going to explain everything clearly. Let's go through it line by line together. Here's the complete code. You can download this from the link in the description. Okay, let's break it down. At the very top we have constant lead pin equals 9. Let me explain what each part means. The word const means constant. This value won't change during our program. Int is short for integer, which means a whole number. Lead pin is just a name we chose for our variable. We could have called it anything. 9 is the actual pin number we're using. So in plain English, we're saying, hey Arduino, remember that pin 9 is connected to our LED, and don't let me change this by accident. Next is our setup function. This code runs exactly once when you power on your Arduino or press the reset button. Inside setup, we have just one line, pin mode lead pin, comma, output. This tells the Arduino that pin 9 will be used to send signals out to control our LED. We're setting it as an output pin instead of an input pin. Think of it like telling the Arduino pin 9 is for controlling things, not for reading sensors. Once we set this up, we can start controlling our LED. Now we get to the loop function. This is where all the action happens. Everything inside the loop function runs over and over again forever. That's how we create the continuous fading effect. Our loop has 2 main parts. First, we fade the LED from completely off to fully bright. Then we fade it from fully bright back to completely off. Then the loop starts over and does it again. Let's see how we make that happen. The magic function here is analogWrite. This is what actually controls the LED brightness using PWM. Here's how analogWrite works. It takes 2 pieces of information. First, which pin to control, in our case, lead pin, which is pin 9. Second, a brightness value from 0 to 255. 0 means completely off, no light at all. 127 is about half brightness, medium light, and 255 is maximum brightness, full power. So if we write analogWrite lead pin, comma 100, the LED will be dim. If we write analogWrite lead pin, comma 255, it'll be super bright. We can set it to any value in between for precise brightness. Go to the Tools menu. Under Board, select Arduino Uno. Then under Port, select the port where your Arduino is connected. If you only have one USB device plugged in, there should be just one option. All right, let's upload this to your Arduino. Now click the Upload button. It's the arrow pointing right at the top of the window. The Arduino IDE will compile your code and send it to the board. You'll see the RX and TX lights on your Arduino blinking rapidly while it's uploading. Wait for the message at the bottom that says Done Uploading. That means your code is now running on the Arduino. And there it is. Look at that smooth, beautiful fade. The LED gradually brightens, then gradually dims over and over.